have to share our profits with anybody. We reinvest our profits in developing more products and influencing research and advancing research, and acquiring new solutions. We are an incubator for innovation. So that's what we do. So we are a commercial company because that's how we found the other companies, but we do not make money, if that makes sense. We create money, but we don't share that money with investors. We reinvest all that money. And the mission is forging partnerships to overcome global research challenges, as I said. So it's not a for-profit in that sense. Okay, a little bit about open science. Open science is a set of principles and practices that aim to make scientific research from all fields accessible to everyone for the benefits of scientists and society as a whole. And I'm quoting from the Open Science Handbook, the UNESCO recommendation for open science. I expect you will be familiar with this. Any of you that have read it or have participated in any of the working groups or know anything about it, please raise your hands if you are familiar with it. Just one person?
You don't know open science.
Okay. Well, the UNESCO recommendation in open science is something that you should be all familiar with around the world. Countries have subscribed to the UNESCO recommendation of open science, member states. So go and find out whether Ghana has, what they're planning to do about it. But it's about using open licenses to share publications, data, software, and hardware more widely, not only with each other, among researchers, but with the rest of society. So open science is about making sure that not only scientific knowledge recognized partner, and this is a lovely letter that we received last year in February from the Assistant Director General for Natural Sciences, which is the leader on the open sciences of UNESCO, about our efforts. So it says we share efforts not only share and storage, but also enable citations for the range of scientific knowledge products and a valuable contribution to the global efforts for open science. We acknowledge these efforts as contributing to the pillar of open scientific knowledge and the transformation of research assessment based on a more comprehensive and equitable framework. I'm pleased to welcome Fixet to the UNESCO Global Open Science Partnership. We look to the Global Open Science Partnership for technical advice and guidance as we support countries around the world to implement the UNESCO Open Science recommendation. So what that really says is that at Fixer, we provide the technical support, the guidance, and not just the infrastructure, but all of this that I'm doing today here with you, that Joe is doing with you as well. We provide the guidance. We provide the strengthening and capacity building workshops for you to understand how it's all part of the bigger picture of the open science picture that is global and is coming. And you can choose to jump on the boat and come with us, or you can stay behind. It's your choice. But it's all important to understand in the bigger picture. So making the transition. This is what the research data management landscape looked like a decade ago. And perhaps it's a picture that is familiar to you all. I don't know. Yeah? Okay. But this is what it looks like today. Well, this is in the US. It's an image from the Pittsburgh Supercomputing Center. But I'm sure there is computing centers like this in Africa or in Ghana. I don't know where, but I'm sure you know that. Because this is what it looks like now. And how do we go from open access to open science? The transition from open access to open science requires substantial infrastructure and technological changes. Many institutions around the world have moved or are moving from institutional repositories, such as the ones that you have, your DSpaces, of open access publications, where you have your thesis, your dissertations, you have your publications from your researchers, to data repositories, or full institutional repositories, that all-in-one repositories that have data but also have the publications all in one place. So many institutions have moved or are moving from those institutional repositories to the full institutional repositories to set the methodology and supplementary materials that gave rise to the publications and link everything together. And here's the key, the linking everything together. So you will have, and later on I will show you the workflow actually in Pixel, so you can understand it, but it can work in any other data repository. I'm not trying to sell you one repository. I'm trying to explain the concept. When you have a publication in your DSpace, you have the publication in there. But where is all the data that we have talked about this morning that gave rise to the publication? Where is all the research? Where is the interviews, the videos, the experiments, the code, everything that they might have created as they were researching your researchers? So everything needs to be available, shareable, and linked together so you can get back to the source. And that's how research advances research much faster. So the open research landscape in repositories. Universities have been using repositories to store theses and other documents since the 80s. I don't know whether that's when you started, I suppose not. But in some parts of the world, and the UK is quite advanced in that field, and Australia is quite advanced. Not the US very much, to be honest, but Australia and the UK and some parts of the Nordics in Europe started using repositories to store theses and documents in the 80s. In the 90s, most universities have repositories to store and share theses and journal outputs, which is what I understand most of you have now. Although some of you said that you still don't have repositories, not even for publications. Around 2015, universities start to add the research data to repositories. And I just mentioned when Mark Hanow, our founder, decided that he needed a data repository and he couldn't find one. That was in 2012, he created one. So that's when data starts being heard about and people start finding the need. And by 2020, the next generation repositories, which is the ones I'm talking about, started coming into form. So the open research landscape has repositories that are next generation repositories. And they are, as I said earlier, about what they connect to as much as they're about the content that's hosted. So it's not enough to have a repository and to put content in there and to make it publicly available. It needs to connect to other things. It needs to be interconnected, interoperable. And Joy was talking about this morning. So here's the introduction to open data repositories. Research data ecosystem, very simplified. So you have your domain-specific repositories. They are repositories for specific disciplines, like chemical sciences, for example, one that speaks to mine. Then you have your generalist repositories where you can put everything, all types of research outputs into any subjects. And then you have full institutional repositories. Those are not just institutional repositories like the ones you have, but full institutional repositories that get data and all types of publications. Everything that you can collect can be put into the repository. And here are some of the open data generalist repositories. Some of them you might be familiar with, some of them you might not have heard about, but I suppose you all have heard of Zenodo, Dataverse, Dryad, Mendeley Data, and Pixel. So when they were developed, they came with a complete solution for collecting, storing, displaying, and reporting on all research outputs, contributing to the quality assessment of data sets. And I mentioned quality assessment earlier on this afternoon. And that's important because, again, you need to be able to assess the quality of the research that you are reading about, that you are accessing. So here are some images of some of the things that you can find in Spixer. There is more than 8 million items in Spixer at the moment. That includes institutional repositories, plus government-funded repositories, plus publisher repositories that we create for publishers, plus the Spixer.com that I mentioned that is free to deposit in. So altogether, there is more than 8 million different outputs in there with individual data side DOIs. And some of them look like this. This is a video, which is an example of a sat-nav close-up, something to do with astronomy. And you can actually, if you were to go into this, if I were to share the DOI, and I will share that in the slides later, you can actually play the video on the browser. You don't even have to download this content to be able to see this video of this sat-nav close up into, in a space into some part of the world. In here is something to do with the heart. So it's quite clear that this is a picture of a heart somebody has made. It's part of the data set, and you can see, if you see on the top of the image, you can see all the files on the data set. Again, all of these are viewable on the browser, so you don't need to use egress and regress costs for uploading and downloading things into your computers. And that is very important for data usage, your own data, to visualize things, your researchers' data. This is an article. The important thing about the article is it has a data availability statement. So it connects with the data and the code that we put the findings in the work. So it says all data and code used to generate the findings in the present work are publicly available up, and they're in GitHub. So it takes you directly there. And in GitHub, you can then, if you want, download the code and start using it because it's open source. This is how everything is linked together. So that's the samples. So linking papers to the supporting data in a repository was associated with an average of 25 increase in citations. And here's the important bit, because that's what your researchers want and need, doesn't it? Citations. They need citations. So linking the papers in your DSpaces to the supporting data for those papers will help them increase the number of citations. And 25% is quite a high number. This is according to PLUS in 2024, and they were one of the first academic publishers to put forth this data availability policy that they had in their publications. 6 years later, this study came about, looking at more than 500,000 articles and their corresponding data availability statements. And what did they find, the authors that did this paper? Well, fairly obvious one is that following the mandates that the publisher policies had, the data availability standards became very common. People started using their data availability statements. The authors found that an association between articles that include the data availability statements that links the data to the repository to the article, the data in the repository to the article receive up to 25% higher citation impact on average. So this is why it's work. And the founders took notice, and then the founders started also asking for the data to be made available. So that's how it started. It started with the publishers, and then the founders have asked for the data to be made available. This is just citations of data in generalist repositories, and it takes you through all the different repositories and how the data availability statements have increased the number of citations when they started. So an effective transition requires data management policies, and we have spoken about data management policies quite a bit already this morning. The NIH, which is the biggest funder of research in medical research in the US, has issued, they were the first ones to issue this amazing seismic mandate, as they call it in Nature in this article, share data publicly. That means that if you want some research funding, you have to share not just the results of your research, but also all the data that you have created as a result of the funding with the reference team. And they are not the only ones. There is lots of funders now that do that. So again, these are the reasons why your researchers need to have the ability to be able to share the data, not just the publications, because the publishers, where they publish, and the funders that are funding the research has asked them to share the data. And if they don't have data repositories provided by the institutions, where will they go? So this is the problem that you should be solving for them. This is what the mission of the library should be. I hope this makes sense. So again, the NIH mandate and generalist data repositories, it says that while the NIH encourages the use of domain-specific repositories, we talked about them earlier, where they are possible, because in some domains they are, such repositories are not available for all data sets. When investigators cannot locate a repository for the discipline or the type of data they generate, a generalist repository can be a useful place to share data. Generalist repositories accept data regardless of data type, format, content, or disciplinary focus. So that's where he says it's a generalist repository that works for all types of data. And we have a project with the NIH and the other repositories that I mentioned, because we all work in collaboration to create a better ecosystem research and research data. So, just to put it all into context, above all, an effective transition from open access to open science requires a shift from the main actors, researchers themselves. Obviously, they're the main actors, and we heard this morning that some of them are still too scared to put things publicly available in case something happens to the data, and the institutions which host them, and this is where you have a role to play. Academic libraries can and should provide research data management services, including the infrastructure required to facilitate data sharing and training on open access sharing, the FAIR principles and licensing. What you were saying this morning as well, but it's up to you to provide the training. That's why we are here to support you getting trained yourself, so then you can go and pass on this knowledge. So this is the end of this part of the presentation, and I welcome your questions. Joy, perhaps you can help me. I will sit down for a couple of minutes and see if there's any questions for the next slide. The next one, so it's number 4. Anybody? Any comments to the presentation? Did it make sense? Yes. Has the presentation got you thinking about what you currently have and what you need to have, and what is the road from the open access to the open science? There is an open. There's a hand in there. Where's the mic, please? Yes, please. Yes, raise your hand again so they can come to you.
Thank you. Very nice presentation. Talking about the data on open science. As at now, we all know most of our universities have their own repository without the data. So it means we have 3 steps to move forward. First of all, we have to create our own repository for the data and then link it to the general repository. Is that what you mean?
Yes, that's one solution, and I will show you later in the presentation. I'm going to the next, which is Fixer. I'll show you in a specific example. It's not so much talking about Fixer, but how you apply that principle. So in South Africa, they have the database repositories, the same ones that you have, and they maintain them, and they have the publications and the thesis and dissertations in there, and then they have data repositories as well, because it's a mandate of the National Research Foundation of South Africa, and they should have them. And they link one to another. Yes.
Yes, and I know that most of the publishers nowadays will require that you tell them where you have put your data in a certain repository, which is a public repository. I don't know whether in Ghana, apart from South Africa that you are talking about, do you know any other public repository for data where we can deposit our data? Because most of the time they ask us, where have you put your data? And if I say I've put it in my repository in my university, is it acceptable?
Well, if your repository in your university can accept the data, yes, it's fine, as long as you have a data availability statement that links one with the other. The problem comes if you don't have the persistent identifiers that Joy was talking about this morning, so you cannot really link the data properly. And in most cases, if you have the spaces, you will know that there is lots of formats that the spaces don't accept. And so if your data is in a format it cannot get into the repository that you're using, then you have a problem because you cannot put it there.
Yes, because I tried one and it didn't work. So I told them I haven't put it in any repository. Okay. They accepted my paper, all right, but
I'll show you a solution.
Okay.
Let me go and say you the solution because I actually have a workflow and you can use the free fixer version if it's your own data.
Okay.
If it's something that you guys want to publish and it's your own data, you can create an account on fixer.com. As I said, it's absolutely free. You can link it to your ORCID profile and you can sell your data there if it's your own data. Obviously, you cannot sell your researchers' data. It's only for individual data you can sell. You cannot sell data that belongs to other people. So that doesn't solve the institutional if you have one with your CRIS system, if you have one with discovery layers. And although it was born for data sharing, as I mentioned earlier, Pixar can host publications and research data. This is how one of the repositories, this is an institution in Australia, this is one of the repositories that is a full institutional repository, has organized, so you can see how it looks inside. So it's got its name, the call, that's how we call it, and that drop, that's an university, and they have 5 groups. One of the groups in the repository is open data, another one, open educational resources, open special collections, where they have their archival information on museums, open publications, so that's what they used to be a DSpace or something else, I don't know, but this is where the publications are, the equivalent to your DSpaces, and open thesis as well. So everything is in different parts of the repository, but everything is linked together. So this is Fixair's global reach, and how does it look in terms of the map. You probably see that there is a dot in the map in Ghana, because we do have a repository in Ghana, but mostly in South Africa and obviously other parts of the world, in South Africa, New Zealand, Australia, in Europe, in the US. So initiatives in Africa. So we've been providing equitable price repository infrastructure, supporting strategic partners in the continent, and contributing to thought leadership and capacity building, as we are doing today. So this is the sample in South Africa that I wanted to share with you. I have some of these posters printed if somebody wants to read it and see it, but it's also available online, so you can go to the page and see it. So we've been providing quality, affordable data repository infrastructure to South African universities since 2019. I just explained earlier why it came about, why the need came that they needed to have data repositories on top of the spaces that they were already having. And we work with Tenet, which is the equivalent of Garnet, and we have a consortium with them since 2020. So through them, we are able to provide this equitably priced repository infrastructure. What that means is that they pay a subscription price that is a price specifically for them. It's not the same as other partners in other parts of the world will pay. And this is the page, so you can go in your own time and have a look at it afterwards, or you can just Google Fixair in South Africa and it just comes up. So at the moment we have a very strong and mature research community. The repositories, the data repositories are quite large, some of them. There is 17 individual data repositories from institutions in there, 17 universities, and there are more coming, and there is a couple in implementation at the moment that are going to go live, including a research institute, not a university, but a research institute, a national research institute, so the equivalent of your Kinderpol Health Research Center, for example. Now, sharing a wide range of research data outputs in all disciplines. So you can access all of them individually in that page that I mentioned, but we also build an aggregated repository, so you can search for all of them at the same time. So this is the Discover Research from South Africa. So effectively it's a data repository at the national level. So all the research from all the South African universities that contribute to their individual repositories are aggregated there in a federated search. So making South Africa research data more visible, so visible to the world, makes it necessary. And this is how it looks like. As you can see, the group structure, each of the individual universities is there. You can click on them, have a look at them individually, but also you can see all the research together and search in there. We also have a partnership that is very exciting to promote open data awareness and participation in Africa with AFLIA. Our colleagues from AFLIA here. Wait, both of you. Thank you. We signed this last year at the conference. No, before the conference. I came to the conference afterwards, but we signed this. And I have to acknowledge both of your contributions. Making all the hard work of actually doing the drafting of the documents, all the legal processes, and all the everything that we did. And again, Nikia is a code that you can scan if you want to print so press release. And we have a repository for the AFLIA conference proceedings. You want to say something about it? Because you actually manage the repository. No? Do we have a microphone, please?
Yeah, all right, thank you. I'm Stanley, research coordinator at AFLIA. So like Maria mentioned, we have a standing partnership with Fixture because we believe in very much in the principle of open data, very much in the principle of disseminating scholarly communication or resources openly. And so when we started the conversation and we realized that this buys into the vision of the organization, we went all in, and thankfully we were able to complete the partnership. And the last year's conference, AFLIA conference in Accra, we have all of the outputs and proceedings and resources that were generated uploaded on the repository, which is open access. So yeah, it's this is the fruition from the partnership, and we believe we're going to be doing more. And as the Continental Association for Library Institutions and Associations, we believe that this is a good example that other institutions can follow. Thank you.
Thank you so much. Okay, I can see you're all a bit flagging. And I don't want to be talking too much because you're falling asleep. But has anybody visited the AFLIA repository or knew that it existed? Has anybody contributed to it? Perhaps some of you were there last year, had any papers? No? It's all news? Nobody went to the conference last year? Some were there, I know, because I recognize the faces. Okay. I love that our paper is there. Joy and I did the paper, and it's that one, the first one there, supporting the colonization of learning in Africa. But please go and have a look at that. Again, you can just Google it and it comes up. So we also are contributing to thought leadership and capacity building by doing seminars and workshops like this one, and supporting partners by sponsoring and speaking and sharing conference sessions in different parts of the continent. So I've been in Botswana, South Africa, where we had an Open Science Day with UNESCO as part of the Open Science Initiative, and we spoke there. In Ghana last year, as I mentioned, in Zambia, in Uganda. I'm going to Kenya next. These are all Zambia, Uganda, and Kenya, and this one are the national conferences for the national consortium. So talking to librarians across the continent and delivering webinars as well. I'm very active within IFLA. I've been for over 20 years now, so I have lots of colleagues. I've done webinars for the Africa region earlier on this year. For Ubuntu Net Alliance, which is the equivalent of Walkren, perhaps you know about them. And we are doing one with GTEC in June as well. So, is something going on? Oh, okay. So Fixer provides persistent identifiers for fair sharing. And these identifiers, I'm going to speak about 3 of them very quickly because we already have heard quite a bit, but I just want to show you what's the difference in between what you currently have and what data repository or a next generation repository can provide. So DOIs for research outputs, ORCID for individual researchers that we mentioned already, and ROAR for research institutions.